Hi guys, so today we're going to look at a new way to solve systems using something called row operations. So in order to do row operations, what we first need to learn is something called a matrix. So what a matrix is just an array of numbers. Basically it's taking the values and putting them in a rectangular form. So a simple matrix is something like this. That's what a matrix looks like. It's just a set of numbers. So what we're going to do is we're going to find what's called an augmented matrix for this system. And what that means is we're just going to list basically our coefficients, and we're going to put them in a set of brackets. So the coefficients of my first would be 1, -2, 3, and 9. Then -1, 3. If you notice, there is no 0, so I'm going to fill in a 0, then -4. Then 2, -5, 5, and 17. Now, typically when you see the notation for an augmented matrix, you're going to see something here, just to show the difference between the variables versus those constants. So sometimes it's a line, sometimes you'll just see some colons, sometimes you'll see a dotted line, sometimes you'll just see one colon, a couple of different ways you could see it. But usually there's just typically something there to differentiate, hey, these are the coefficients of the x, y, z, those are the numbers on the other side of the equal sign. Right, so this is an example of a matrix. Whenever we talk about a matrix, it has a certain number of rows and columns. We list the rows first. So we would say this is a 3 by 4 matrix because there are 3 rows and 4 columns. Even though there's that line there, that doesn't change how many rows and columns are in it. We're just using that line so we know what those numbers stand for. All right, so let's go ahead and look at the next one. Let's write that augmented matrix. So I'm going to start with the coefficients. So 1 for the x, -6 for the y, 0 z's, then 5. Then there are 0 x's, 3 y's, 2 z's, and 4. 2 x's, -5y, -1 z, and then 0. And then we'll just do something there to show the difference between those things. And I'm going to go ahead and make a full line there, just because that's how I'm used to seeing it. Now, the reason that augmented matrix is important is it can help us find another way to solve systems. So what we're going to do is we're going to use our calculator to find something called reduced row echelon form. What reduced row echelon form does is it takes our matrix and it puts it in a form where on the left side we're going to have a diagonal of 1s and a bunch of 0s and then some numbers. And because that matrix represents a system, the way it's going to work out, because that first column were all of my x variables, then it's going to tell me what x equals whatever number is at top. Then it's going to tell me that y equals this number and z equals that number. So this is going to give us actually a really easy way to solve systems using our calculator. So go ahead and get out a calculator. All right, so from our calculator, we can get to matrices a few different ways. So first of all, what I want to show you is probably the part that most people forget is where to find this reduced row echelon form that we're talking about. So to do an operation on a matrix, we're going to go to option. So if you see option, we'll click that. Then you'll see up here we've got a couple options. One of them, it says MAT. MAT stands for matrix, and this is where we're going to find all of our matrix operations. So the operation that I want to do, I want to go over to this arrow so I can see more options, so F6. The option I want is this RREF, which is under F5. So I'm going to go ahead and select RREF. That stands for reduced row echelon form, which is what we want to be able to find our answer simply. So what I'm going to do now is I'm going to actually enter my matrix. So in order to do that, I'm going to click exit until I get back to my normal menu options here. So now I'm going to choose the option that says math, and then I'm going to do MAT for matrix. Now this time you'll see a 2 by 2 and 3 by 3. We're going to select M by N because we want to enter a matrix that has 3 rows and 4 columns. So what that does then is it gives me those blank numbers so I can now type in that augmented matrix. So go ahead and type in the augmented matrix for this system. All right, so once you've typed in your augmented matrix for that system, then what we're going to do is we're just going to press enter. And that's going to tell us our solution. So remember the way this corresponds. The first column was our x's, so this is telling me that x equals 7. The second column was y's, so y equals 1. The third column is z, so z equals 5. So this gives us a very easy way for us to be able to solve these 3x3 systems. All right, so if you feel comfortable, go ahead and try the same process for B. All right, so if you look at your solution here, we'll go ahead and show you there's my augmented matrix. Again, don't forget to fill in those zeros for whenever you fill in, they don't have an X or you don't have a Y or you don't have a Z value. You need to put in a 0 there as a placeholder. But you'll notice on this, it's going to give you kind of some ugly X, Y, and Z values. This is why it's really helpful. That's not the one we really want to solve by hand. So if we were to solve this, X would be negative 11 over 17, Y would be negative 16 over 17, and Z would be 58 over 17. All right, so what we're going to do now is we are actually going to do what the calculator is doing, and we're going to use row operations to get a matrix in this row echelon form, and then eventually it's reduced row echelon form. So in order to do that, the way these work, you really have 3 different things that you can do to this augmented matrix, and that's kind of a little bit of a puzzle trying to figure out what to do to get it in the form that you want. So the things that you are allowed to do are what are called elementary row operations. One thing you can do is you can interchange 2 rows, so you can just swap any 2 rows that you want. You can multiply a row by a constant. So you can take a row and multiply it by 4. You can take a row and you can make it negative. You can take a row and multiply it by 1/4, which is really just dividing it. All right. The last thing you can do is you can add a row to another row, and you can add a multiple of that row. So I could take row 1, and I can add row 2 to it. Or I could take row 1 and I can add 3 times row 2. So what we're trying to do here is we're trying to get this matrix in what's called row echelon form. So if you notice, this is different than reduced row echelon form that we just saw. Row echelon form for a 2x2, we still have 1s on the diagonal, and we still have a 0 in this corner, but this number, that can be anything. That doesn't have to be a 0. In reduced row echelon form, it is a 0. All right, so our goal is to put our matrix in that form. So we're going to start with this first one. We're going to write our augmented matrix. So 1, 1, 1, negative 1, 1, 1. So in order to get that 0, what I want to do is I want to try and get the 0 first. Now, because I can swap rows, it doesn't matter which of those becomes the 0, but eventually we'll move it to the bottom. So in order to get a 0, the easiest thing to do is to take this second row and add the first row to it. So if I take that second row and add the first row, negative 1 plus 1 is 0. 1 plus 1 is 2. 1 plus 1 is 2. The first row has not changed. All I have done is taken the second row and added the first row to it. Now, what I need to do is I need to have 1s on my diagonal. Well, one of them already is a diagonal. The other one's not, so this 2 needs to become a 1. And the easiest way to do that is to divide by 2, or multiply by 1/2. So I'm going to take 1/2 of that row, which turns it into 0, 1, 1. Now the reason that we like this row echelon form, it's not all the way at that reduced form, but it makes it really easy to solve this system, because the system that corresponds to this matrix, x plus y equals 1 is the first one, and y equals 1 is the second. Well, now it's really easy to find that x value if I know what y is. If y is 1 and x plus 1 equals 1, then x equals 0. And I have both my values that I need. All right, so now let's try another one. Same process. We're going to start with the augmented matrix. And I need to get a 0 in either of these 2 places, okay? Because again, we can always swap rows if we have to. So what I'm going to do is I'm going to take the bottom row, and then I'm going to want to add 7 times row 1. Because if I do 7 times negative 1, well, then that's going to be negative 7, which will add to give me 0. So 7 plus 7 times negative 1, that's going to give me 0. Then I would do negative 3 plus 7 times negative 1, which gives me negative 10. Then I'm going to do 18 plus 42, which gives me 60. Now again, the top row here did not change. We only use the top row to help us get to the bottom. Well, now that we're here, I need to get those 1s on the diagonal. So very easy, multiply by that constant. So multiply the top row by a negative 1. So So that's 1, 1, negative 6. Bottom row did not change. And now, except I changed it. So the bottom row is 0, negative 10, and 60 still. And then I'm going to do negative 1/10 of that row. And that makes that row now 0, 1, negative 6. So now when I solve this system, I know that y equals negative 6. I know x minus 6 equals negative 6. So x equals 0. Now let's say we want to do all the way to that reduced row echelon form. So what I would do is I would take the row echelon form, and now I need to get a 0 also in this place. Well, the way I would do that is I would add a multiple of the bottom row. So I would subtract row 2. So that would give me 1 minus 0, 1 minus 1. Negative 6 minus negative 6 is negative 6 plus 6, which is 0. And now I'm in that reduced row echelon form, so I can easily see x equals 0 and y equals negative 6. All right, the last thing we're going to do is we're going to look at this same process with a 3 by 3 matrix. So this is where it gets a little bit trickier because there's a lot more things that we can do with these rows. So, but again, I'm going to start with the augmented matrix. So 1, negative 2, 3, 9. Negative 1, 3, 0, negative 4, 0, negative 5, negative 14, and negative 23. Now, when it comes to this process, the way I'm going to do this is not the only way to get to the right answer. There are different ways to do these operations. But what I'm going to do to start, I'm going to go ahead and try and get I already have a 0 in the bottom left, which is good. Typically, the order you want to do these is you want to get 2 zeros in that first column. So I already have 1 0 there, so that's good. So now I want to get a 0 in one of those two places. Well, the easiest way to do that is going to be to add those two rows together. So it doesn't matter which one you do. I'm going to go ahead and take the first row and add the second row to it. So 1 plus negative 1 is 0. Negative 2 plus 3 is 1. 3 plus 0. 9 plus negative 4. So now that I'm here, now that I have both those zeros, my next goal is going to be to get a 0 next to it. So I'm going to want either this 0, this to be a 0, or this to be a 0. One of those two. And then in order to do that, I want to use an operation with one of those two rows. I don't want to use an operation with this second row because that second row then is going to change that first value that I already worked to get the 0 on. So it doesn't matter which one you do, but what I would recommend is if you can avoid fractions, avoid fractions. So if I take the first row, in order to get 0 in this first row, I would have to do a multiple of 1/5 of that third row, and that's going to get me some ugly fractions. So instead, I'm going to take the bottom row, and I'm going to add 5 times row 1. So that's going to give me 0 plus 0 is 0, negative 5 plus 5 is 0, then it's negative 14 plus 5 times 3. So it's negative 14 plus 15, which is 1. Then it's negative 23 plus 5 times 5. So it's negative 23 plus 25, which is 2. So now that I'm at this point, I'm really close to getting to the form I want it to be in. Because the form I want it to be in is I want to have a triangle of zeros here, 1, 1, 1 here, and then this can be any number. It doesn't matter what those are. What I really want is the triangle of zeros and the 1 on the diagonal. So one of the operations we said we could do is swapping rows. So let's go ahead and swap row 1, row 2. All right, row 1 and row 2 have been swapped, so now I have my triangle of zeros, and I almost have my entire diagonal of 1s. The only thing I'm missing at this point to get that diagonal of 1s is multiplying that top row by a negative. So now I have 1, negative 3, 0, 4. And now this is in row echelon form. So row echelon form, again, what we like about this creates one of those really easy system problems. So setting up the equations that go with that, x minus 3y is equal to 4. Y plus 3z is equal to 5. And 1z is equal to 2. Well, now I know z is 2. Take that and plug it in. Well, y plus 6 equals 5. So y is negative 1. Take y, plug it in. X plus 3 equals 4. So x is equal to 1. So that gives us another way to solve these 3 variable systems. Again, you can go and check these on the calculator by doing that RREF form. You also can do these operations within your calculator. We're going to talk about that in class if that's something you want to try and do. The last thing that we're going to look at is taking this matrix one step farther and actually doing the operations to get it into that form that we're using, that reduced row echelon form. Now, we will not need to go this far to be able to solve these systems, but I want you guys to see what's happening and how the calculator is actually getting what it's getting. What this does, it uses a process called Gauss-Jordan elimination, and we're going to use those row operations, and again, we want it to be in this form, so we have the full diagonal. Well, right now, the problem we just had, I already have this part. So I only need to get those last 3 zeros, which are actually pretty easy based on what I had. So I'm going to rewrite exactly where we just were at the last step. So I was at this matrix where I had 1, 1, 1, 0, 0, 0, negative 3, 0, 3, and then I had 4, 5, and 2. Well, in order to get here, there's really only 2 things I need to change. This one and this one. So it doesn't matter which one I do first. Let's say I want to go ahead and get rid of this 3. Well, in order to get rid of that 3, I want to subtract a multiple of the last row. I don't want to use the first row because if I use the first row, that 1 in the beginning is going to change that 0 that we already have, and we don't want to change that. So I'm going to use a multiple of that last row. So I'm going to subtract 3 times R3. So that's going to give me 1, negative 3, 0, 4, 0 minus 0, 1 minus 0, 3 minus 3 is 0, 5 minus 3 is negative 1. Then that bottom row did not change. Then to get to that final step, I just need to get rid of that last one. I need to make that a 0. And in order to do that, I'm going to need to use the second row because that 0 there is multiplied by anything to get a value. So what I'm going to do here then is I'm going to add 3 times row 2. So 1 plus 0, negative 3 plus 3, 0 plus 0, and then I'm adding 4 plus negative 3, which is 1. The other rows did not change. And now I'm in reduced row echelon form. Again, you will be able to get this from the calculator. We're really only going to go as far as the previous slide in here, but it's good for you guys just to know kind of what's happening here with this process because this may come up in later classes for you. Once you get to this point again, this just tells us x is 1, y is negative 1, and z is 2. All right, so that's it for row operations. Again, in class, we're going to talk about how to actually do those row operations on the calculator if you want to see that process. But again, now it's just being familiar with these different forms and how we can use them for systems.